Hey YouTube, it's JP Dillon. Welcome to part 2 of the 1987 Toshiba 2036 Blackstripe FST set. In the last video, we discovered that I hurt the jungle IC when a solder blob got on 2 pins and it went unnoticed. So I had to get a new jungle IC, which was entirely possible, and they are readily available, at least in 2023 they are. I don't know when you're watching this video, but hopefully they still are if you burned one of these up. So anyway, we're going to replace the jungle IC in kind of abbreviated form, and then we'll get back to troubleshooting the real reason why this set is here, and that is because of the vertical output failure. And we partially restored vertical operation by recapping the vertical section in parts of the jungle IC before we made the mistake and burned up the chip. So we don't have full raster yet, so there's still something amiss that we need to discover, but first, before we can do that, we got to put the jungle IC in and hope that the set still works. So that is the dude in question. And as you can see, in order to get to it, we need to remove this shield, because the other half of the chip is underneath the shield. But once we do that, we should be able to get this out no problem. Alright, so here we are at a somewhat better angle. And I'm just going to take this shield up. Apparently is already up at that point. Those are kind of busted loose. Alright. That was easy. And so now essentially we're just going to wick away the old solder here. I'm trying to do this in such a way that you can see what I'm doing and you don't have to look at my hairy hand. I think there's like 64 pins on this thing. It does quite a bit. Thankfully, the chem wick makes quick work of desoldering. I don't have to worry about ungluing foil traces or anything like that. A lot of people ask me in my videos what I use. That's it right there. Good stuff. Not cheap. And once we get this, all the solder off, then the chip should just come out with relatively no effort whatsoever. That's almost one side. There's a couple up here that didn't quite. Remove all the solder. And when I got one row done, what I'll often do is get my X-Acto and just rock the pins here and make sure that they're actually free. Helps it to come out easier. This was an example of me making a mistake because I didn't slow down enough to pay attention, double check my work. If I'd have noticed that error before I reassembled the set, then we wouldn't be in this predicament. And this is not a customer set, this is my own set. And this is one that I wanted, that I acquired, so thankfully that's not going to set back a repair timeline or piss off a customer. And when you make a mistake like this, you own up to it. I'm perfectly willing to admit and show on camera that I make mistakes, because we're all human and we make mistakes, and hopefully we learn from them. Although I've been doing this long enough that I think I still have a lot more learning to do. We're almost done with this side. Just cleaning the rest of this up here. There's one down here. It looks like it's still soldered in. And we'll rock these pins back and forth. Just make sure they're loose. I think there's one up here. This one right here doesn't look too loose. Let's get the remainder of solder off that guy there. Okay. I'm going to flip the board over. And I change camera angles here. And we'll see if I can get this chip out with relative ease. And I'm just going to get the butt of the screwdriver under here just a little bit. Just to kind of get this up. Taking care not to injure anything more. Now let's see if I have a hook tool that'll work a little bit better. Let's try the hook tool. Get underneath the IC and give it a yank. There we go. Other side. And she comes out. And there it is. So before I do something stupid and reinsert the old chip by accident, I'm going to put a nice red mark on this one so that we don't use it again. That's the dead one. And now, bear with me a moment and we'll get our new chip out of the packaging, which has been overpacked, and I don't like it when people do that, but that's just how it is. I am thankful that somebody had this. All right, and so here's our brand new TA8677N. Now this is obviously a new old stock part, and I can tell that because if we look up close, assuming it will focus on that, we can see that the pins have a little bit of oxide on them. That's from sitting in the parts bin for who knows how long. So before you go soldering on one of these, it's a real good idea to take something like an X-Acto knife and scrape off the oxide from the pins. And so I'm just going to scrape off this side here, and we'll do the other side. And that's so that we have a nice healthy contact for the solder. And I'm going to do the bottom side. This also means that there will be less time that your solder needs to adhere to the pins, therefore transferring less heat to the pins and inside the chip. Because the last thing I want to do is burn up another chip. These weren't terribly expensive. This was about $13. But why screw it up if you don't have to? So we're going to do a test fit and just see. It should just drop in. It drops in on that side. But the pins are not, the pins are splayed outward. So I need to correct that. We'll get our hook tool and remove the chip again. And what I'm going to do is just place it on a flat surface temporarily and bend all the pins. So I'm going to use the shield for that, since it shorts all the pins together and prevents a static buildup. And we're just going to bend the pin slightly flip it over and do the same thing. And then we'll check fitment again, making sure that we absolutely put it in the right orientation. Needs a little bit more correction. So we'll do bendy a little bit more. And check it again. The last thing you want to do is bend or break off one of these pins. It should go in real easy. Yeah, see, it's fighting me, so don't. I'm going to bend this a little bit more on this side. If it's fighting you, don't force it. Correct it, because it should literally just drop into the holes. If it doesn't, you got work to do. It's just this one side wants to fight me. Let's bend a little bit more, just a little bit. Gotta be really delicate. Okay. Yep, just drops right in. That's exactly what's supposed to happen. Alright, let's flip the board over and change vantage again. We want to make sure that every single pin on that IC is through a hole. And it looks like it is. This back corner here, though, I'm a little concerned about. But yep, they're all through the holes. Let's go ahead and solder it in, and then we'll double check everything to make sure there's no shorts. All right. So everything's pushed through. And I solder these in groups to transfer as little heat to the chip as possible. So we're going to do that small batch there. And then we're going to go to the lower side here. I do not like working on small stuff like this anymore. My hands are not steady. At least not like they used to be. And then we'll alternate up here. And again, the purpose of this is to prevent heat saturation on the IC. Because heat kills. And if you saturate the IC, like one side of the IC, and the die gets too hot, it can injure the IC internally. And then so you've gone through all this effort, and whoops, now you don't have a working chip again. That was almost a solder bridge. And I'm sorry if you guys can't see all of this, but I just have to be as careful as possible here, since I don't want to make another mistake of killing the new jungle IC that I'm installing. This is just one of those slow, mundane processes you don't rush yourself on. Remember what happened last time we rushed? Is we killed this part. And there's another almost bridge. Caught that one. All right. Got a couple more left. Okay. Now what I'm going to do is take this pick tool and I'm going to run it between each and every one of these. And if it hangs up, then I know that there was a solder bridge there. They should just pass through without an issue. And if it hangs up and there's a solder bridge, then we take the butt end of the X-Acto and we break the bridge free. Because I don't want there to be any chance that there's another short circuit. So feel free to skip over this part. Fast forward, whatever you want to do. This is going to take a bit. And we'll take a brush and brush it away. So far, so good. Haven't found any bridges. Okie dokie. Brush this off. All right, now that we've done that, the chip is installed, and I'm trying to think of anything else that I could work on in this area before I put the shield back in place. That ground tab up there looks pretty shoddy. We're just going to touch up the solder on this because this is pretty bad. This one over here could use a little help. Otherwise, it looks okay. But of course, the main question is when I turn the set on, will it come alive? Or will it, is it a dead man? Now, in theory, the replacement jungle IC should make this thing work really nice. I think I bent that tab a little bit when I got it hot with a soldering iron. Let's move that over just a pinch. All right. We'll just solder these tabs back down. That one could use a little bit extra. And we'll just double check, make sure it's secure, it's not going to peel up. All right, shield's in place. Moment of truth now. We're going to reassemble it enough to run it and see what it does. All right, here's hoping we done good. I hadn't actually nailed it. Still no video. Really? Really? What did I do? Huh. That's a weird one. All right, and we are back. Thankfully, I had just knocked a wire out of a solder pad that went up to the CRT board. I was sweating bullets there for a minute, thinking that was wrong with the video lead had become disconnected. Question is did I do that as a function of the last service and I've been chasing my tail on a bad jungle? Well, anyways, here we are. We're back at where we started with the funky vertical nonlinearity lack of height problem. So let's get back into that one. Okay, so the only thing that's left really in this circuit that we have not messed with yet is C308, which is part of a feedback loop and also works with the height control. And the ESR meter told me that was okay, but you know what? If it's leaky through that 82K resistor, which limits the current, it's going to pull down this source here, and it's going to pull that down, and we're going to get a lack of height. So let's pull that capacitor out and check it for leakage. I bet you it is. Alright, so I got my cap hooked up here. I'm going to do R times 100. Oh yeah, that's leaky. Look at that. Look at that. So, there you go. Let's pop a new 2.2 microfarad in there, because that's decidedly leaky, not even trying to charge. That's what's our remaining problem is. Betcha. Let's go ahead and pop another one in. Alright, moment of truth. Let's see if I was right. Full screen. Look at that. Blammo. And if we adjust our height control, let me get a tool here real quick. See how much range we have. Un momento. Oh yeah, so at minimum we just start to get frame collapse there. We got plenty. Alright, that's the good stuff. Got nice linearity, looks nice and pretty. Still need to work on convergence and whatever else. I've got the screen dim so it doesn't blank. And we still got the yucky convergence. And we got yoke tilt and all that other stuff. And then I'm pretty sure the purity is wrong. There's all sorts of stuff we need to do to this. But we're getting there, getting kind of excited. Yeah, I hate these inline guns for convergence. They're not fun, but we'll work on that in the next video. So we have success in fixing the vertical failure. The remaining stuff we have to do is all real setup type stuff. So next we'll work on the purity, we'll work on the convergence, the yoke tilt, and get everything nice and happy. And then we can put this thing to work. So anyways, hope you enjoyed the journey so far. Stay tuned for the next episode. More stuff to come.